Hello everyone and welcome to this video. So in this video we are going to be making predictions using a machine learning model. So we're going to be learning how to do this, and we have two methods for this. So let's start. So basically in the previous video we learned like sort of how a machine learning model fits data to it. So how does it what is the sort of science of fitting a machine learning model? So we learned that yesterday and it was a very short video. So now we're going to be learning, so this is 3.2. We're going to be learning how to make predictions using a machine learning model. Okay, so we're going to be learning that today. And actually, so there are actually two ways to make predictions. So the first way to make predictions is using the predict method. Okay, so we've used this before, and then the second way is to use the predict prober method. Okay, so yeah, let's start. So we're going to be looking at how to predict using a classification model. So what I'm going to write here is in bold, I'm going to put in making predictions with a classification model. Okay, so what we're going to do now is we're going to learn how to make predictions with the normal predict function. So yeah, so now what we're going to do is here we're going to put a comment saying use a trained model to make predictions. So our trained model over here is basically here, and let's just run this. Okay, so so yeah, that's our score right now. So we're gonna see how it has predicted this. So this is our random forest classifier model. We're going to be using that to make predictions because it's a classification model. So I'm going to say clf.predict. This is just an example. So clf.predict, we're going to use a NumPy array. So np.array. Let's just pass in some random numbers. Let's pass in 5 numbers. So 1, 6, 3, 2, 9. That's okay. So actually, did you know that this doesn't work? Just a little spoiler alert, this does not work. So if we run this, it will obviously give us an error because I told you it does not work. So it says expected 2D array got 1D array instead. So what it's saying is that this array is not enough for to make predictions with our model. Because if we go to our Scikit-Learn mind map, here it says if you can only actually predict, like you can only actually use a machine learning model if you have more than 50 samples. Okay, and basically here we've literally only got 5 samples, so obviously that's not going to work, and we will have to actually have the same number of samples as this. So let me show you. So we'll have to have the same number of samples as x test, which is about, if I check the length, so length, we would want about 61 samples, or maybe even more than that. Okay, so yeah, So what we're going to do is we're going to predict on X test to see what the results are. So clf.predict, we're going to predict on X test. And that is giving us a big NumPy array with about 61 samples. Okay, so is this similar to you? Have you ever seen this before? Have you ever seen anything else with the same sort of layout? Well, we have. So mp.array. Let's look at ytest. See, it is actually in the same layout. So basically what this is this X test over here is basically the machine learning model's predictions. And this over here is like the ground truth. So this is what the array actually says, and this is what the machine learning model is predicting. So we can make predictions with this sort of stuff. So what we're going to want to do to sort of see how accurate our machine learning model was, we're going to want to compare predictions to truth labels. So that is basically this ytest, so what the data frame or array actually says. So we're going to want to compare the predictions to truth labels to evaluate the model. So we're going to do a bit of evaluating here. So usually you'd want to go ypred, so that's the predictions, is equal to clf.predict. So ypred is basically this over here, so this is what the model has predicted. So ypred is equal to clf.predict, and we're going to want to pass in X test. And then what we're going to want to do is we're going to want to calculate the accuracy. So we're going to say np.mean ypred is equals to ytest. So this is going to give us the accuracy value. Okay, have you seen this? You will have. So we're going to say clf.score xtest and ytest. Boom, that's exactly the same value over here. So basically this is exactly the same as trying to do this. And there's also another method which is exactly the same as well. So let's explore that one too. So you could also go from Scikit-Learn.metrics. So we're going to look at this in the next section, not the next video, the next section. So from Scikit-Learn.metrics, import accuracy score. So basically what it's going to do is it's going to give us the accuracy score. So we're going to say accuracy score, and we're going to want to pass in ytest and ypred. So it needs the, so what I'm going to show you is that is exactly the same. So if I press shift tab on here, so this is where you would have got the ground truth from. So it says ytrue and ypred. So ytrue, that basically means the ground truth label. So now once we have learned how to do it with clf.predict, so that is a method you would usually want to use. But there is also another main method that is really useful as well. So I'm going to put in Markdown. We're going to learn how to make predictions with the method predict prober. So you might have not guessed what it does, but actually what predict prober does is, I'm going to write it here, so predict prober returns probabilities. So I'm just going to see probabilities of a classification label. Now that is quite confusing. So we are going to open up a new tab and search this. So we're going to search Scikit-Learn predict prober. So what you're going to want to do is you're going to want to click on the link that says sklearn.linearmodel.logistic regression, and then you will find this a whole lot of code, and it will have loads of weird things on it. Okay, so what we're going to want to do is whoops. So this is actually the wrong page. Hang on, sorry guys. Okay, actually no, it is not the wrong site. So basically what you're going to want to do is, here we have the heading. So you're going to want to scroll down until you see this table over here that says methods. So here's the predict prober method, and it says probability estimate, which is still confusing. So I'm going to click on that, and it's going to say the returned estimates for all classes are ordered by the label of classes. So basically, in this case, the classes for a classification problem would be either 1 or 0. Okay, so those are our two classes that predict prober is going to try and predict. So the parameters is the x, and then we're going to want to pass in the features, but we're only going to pass in x. Okay, so let's do that. So let's go clf.predict prober. So you might think that predict prober stands for predict probability, and it does. So we're going to put in x test. So x test, and whoa, that has given us a lot of values. So let's just reduce it to just 5 values. So we're going to put :5, and there we go. We've only got 5. So let's compare this with, so let's use predict on the same data. So I'm going to write let's use predict on the same data. So basically this is here you'll see the difference. So we're going to say clf.predict, and we're going to predict x test, and we're going to want the first 5 values. So these outputs are rather different. So let's try to spot the pattern. Okay, so here we've got 0, and here the value is lower, but in this section the value is higher. And then here we've got 1, over here it's higher, and here we've got 1 as well, here it's higher, and then the last one's got 1 as well, and here it's higher. Can you spot the pattern in there? What do you think it is? So if you did try to analyze from this output, you would eventually see that it has split up these outputs into 2 classes. So each mini array in this huge array is basically each output. So this 0 would represent this whole array, this 1 would represent this whole array, so on and so forth. So here it sort of gives the probability of which one is most likely, which class the prediction is most likely to be. So here is 0, and here it says that 0 it's 0.89, it's 89% certain that this should be a 0, that the prediction should be a 0, and that is quite a lot. So but here it is not so much of a difference, it's only 2% difference, and then here it's not that big, but then for these two it's quite big as well. So you might be thinking, well, predict is obviously much better because it sort of tells us which one it is. Well, they both actually got the same amount of use, because predict prober If let's say you were in a hospital and you're using this new mechanism, and you wanted to find out, and you wanted to know how certain it was. So maybe if it was really certain, you'd be really certain that the person had no heart disease in this case over here. But if it wasn't so sure, maybe if we just looked at X test, the first 5 values, maybe you might work out, why is our model so unsure? Can we improve this data? Can we try retest the patient? And you'll come up with all of these sorts of questions, and you will make your model much better. Okay? And also, just if you did notice, if you didn't notice, if you did 0.89 plus 0.11, it adds to 1. So obviously you can tell it's 89% and 11%. Okay? So this is how we can predict. Using a classification model. So in the next video, we're going to learn how to predict using a regression model. Okay, so random forest regressor. We're going to be learning how to use that to predict. Okay, so if you like this video, please like and subscribe. That would help a lot. And if you have any doubts, please comment them in the comment section below. And I hope you like this video, and as always, thanks for watching this video, have a nice day. Bye.